Okay, so let's take 2 minutes to think about how we're getting what we're getting when we do a step like this inside of our proofs. So in the even plus even is equal to even, we're gonna have something that looks like 2k plus 2k is equal to 2k. From that point, what I have you guys do is get to 4k. So 4k is equal to 2k. And then what I have you guys do is break apart the 4 into 2 times 2. At this point, what happens is we can realize that what 2k is. So we're gonna have, let's do it in a different color. We're gonna have 2 times k, and what is this equal to? We know that k is an integer, and one thing that I've allowed you guys to take for granted is that an integer times an integer is equal an integer. So what if I go ahead and say, instead of writing k here, which I have, let's change the variable. Let's go in m. Now we'll state something about n. So if we say 2k is equal to m, we now know that m is an integer, where m is an integer because integer times integer is equal to integer, okay? So this is what we got now. So 2k is equal to m. So now what we can do is we can take this m and replace it in here. So let's erase all this. Now we have m. So now we have 2m times 2k. But based on what we've defined m and k as, both of those are integers. So we could say like since m and k exist in the integers, 2m is equal to 2k. Thus, even plus even is equal to even, because that's what we get here. So that's a slightly alternate explanation. One more that I've seen in a few places, and I almost like it more, is what if we factor out a 2 here? So we'll have 2 and then k plus k. And we could do the same thing. So we know that an integer plus an integer is also an integer, like 2 plus 3 is 4, 4 is an integer, all that sort of stuff. So we'll have, you kind of go down the same road of k plus k is equal to m, or something like that, where m is in the integers, okay? If you guys have questions about it, I would suggest, I'll probably throw a link to a YouTube video as well that does this method. Another thing that people do that I've seen is they'll have k1 plus k2, so it's differentiating the k's, and then they'll say this is equal to k3, and where k is an integer. So there's a ton of different ways to do it. It's basically just stating the same thing. If we have an integer plus an integer and an integer times an integer, it's still going to be an integer, so we can still basically get down or boil it down to this 2k on the left side, and that's what we're trying to do in this case. If we're trying to prove something is odd, like we did at the end of class in 8th period especially, we want to boil it down to 2k plus 1. So it takes a minute to go through these. The one thing I do ask is that you do give it a fair shot. Just try to make sense of it. I know there's a couple questions in class. I'm going to try to do my best to kind of refine my explanation so that it's a little bit more clear. So I appreciate it. Give the homework a shot. Have a good day.